Testing, testing, testing. Hi there, guys. My name is Rohan David, and today we are going to be talking about Pascal's law. Today, we're going to be talking about Pascal's law. Okay, so what is Pascal's law? You might be asking. So, it's stated. Pascal's law was discovered by a French mathematician named Pascal. Okay, Blaise Pascal, I think it was. Okay. So what is Pascal's law? It states that when you apply pressure to a fluid in a closed container, that pressure is transmitted equally to every part of the fluid and the walls of the container. Okay? For example, let's say you have a water balloon, you squeeze one side, the pressure, okay, moves all the way to the other side, right? So now let's put up an example here with hydraulics, okay? So here we have an hydraulics over here. If we apply some force on one piston, the other piston moves up. Because when you apply, it creates pressure. And this pressure moves all the way up onto the bottom of the second piston. And as we stated here, it also pushes on the walls, right? And the only thing movable is the piston, so it moves it up. And the thing is, the pressure is equal under both the first piston and the second piston. But one thing we can do is that if we change the if we change the size of the piston, it could change the force of piston 2, okay? For example, let's say we have two pistons. One piston is 10 centimeters in diameter and the other one being 100 centimeters, okay? So when we push down with the force, okay, this creates a pressure change, okay? And this pressure change pushes up the other piston, okay? So we could write it down as this, okay? Now with this, okay, basically, in other terms, how it moves this up is, the force is amplified, kind of, okay? So, as we see here, this is 10 centimeters and this is 100, okay? So the force applied on piston 2 will be 100 times more than the force applied on piston 1, okay? So when you push this will also be pushed up, okay? But this also does not violate the law of conservation of energy because, okay, this is only because of the differences on the size of the pistons, okay? So if we pushed on the first piston 50 centimeters, the second piston would only rise up 0.5 centimeters, okay? That's how Pascal's law works. For example, okay, a jack also works like that. Or maybe a hydraulic lift also can work like that with Pascal's law. So let's say you have a jack, right? You're pushing one side of the piston. There's a one-way door, so we push on it, right? We push it back up. It only moves up that much, right? But if we do it again, and since there's a one-way door, okay, we continuously do it, the piston will continuously move up, okay? That's basically how Pascal's law works. And that's basically it. Thank you for watching this video and hope to see you next time. Bye-bye!